Hey everybody, welcome to Dark Mode, the show where we do sketchy stuff with the Windows API. Since this is episode 1 of a new video series, it warrants some additional introduction. My name is Ryan Reese, and although I do work for Microsoft, none of this content is endorsed or supported by Microsoft in any way. This is just me. What is this video series? What is this show going to be all about? Programming. This is going to be a live coding video series, live coding show where you're going to watch me do strange things with the Windows operating system, the Windows API, deceptive, sketchy, underhanded stuff that, it's really exposing sort of the dark underbelly of Windows programming. What I'm not going to be focused on is like hacking or 0 days. Those are not, those come and go. I'm talking about otherwise legitimate uses of the Windows API, but to accomplish some end that may be slightly unsavory. So the question is, why am I doing this? And the answer is number one, because it's fun, and number two is because even to be a defender, a blue team type of person who defends against hackers and malware and all sorts of malicious threat actors and whatnot. You need to know how the attackers might come at you. You need to know how what malware looks like and how to detect it and all this kinds of stuff. So, knowledge is power. I consider myself more of a blue team type of person. I have more respect for defenders. I think defending is much harder. Nevertheless, I want to do fun stuff and look at malware from a different angle. So, without further ado, like I said, this is going to be a live coding show. So you're going to be watching me program stuff. And for episode 1, what I think we're going to do, how I think we're going to start out, is we are going to write a tool, a utility for ourselves that is going to come in handy later on. So as these episodes progress, they're going to build on top of one another, right? So this tool that we're going to build first on episode 1 is going to be a tool that injects DLLs into remote processes. So I'm going to try to not assume that you know a whole lot. I mean, I'm going to try to explain things as much as possible. What I have here is this is a Windows 11 machine, Windows 11 desktop. The only software you really need is Visual Studio, which you can you can install Visual Studio yourself. Visual Studio 2022 Community Edition. It's free. It's completely free, and you just download that, and it will do everything you need to do. I will say that most of my programming is going to be in C. There's really no need. I really don't have any need for anything else. So you don't have to use Visual Studio if you don't want to. Of course, you can use any compiler that you wish. Clang is on here. I think even when you use Clang on Windows, I think you still need a linker for it, and you can use the linker that comes with Visual Studio in conjunction with the Clang C compiler. I believe there's also a linker called LLD, which I think has a Windows port. I've never used it. You might want to go investigate that. Like if you're really trying to avoid Visual Studio, you can try that. There's other compilers that you can use, but I personally, stick with Visual Studio for now. Um, it works fine for what we need. Right. So what we're talking about is we're going to build a DLL injector. So first, let me go and look in my, let's see, tools, sysinternals, process explorer is what we're looking for. All right, this is Process Explorer. And for those of you who aren't familiar, Process Explorer is basically just a task manager on steroids. It does way more than the built-in task manager. if I click on just any random process here, let's go to LSAS. Okay, so every Windows system has this process running called lsas.exe. And you will see that if you go to view, let's see, we've got show lower pane is already chosen, already selected, and the lower pane view is already set to DLLs. So if you look at this lower pane, it's showing you all of the DLLs that are currently loaded by this process, lsas.exe. Question is, why would you ever want to inject a new DLL, an arbitrary DLL, into a process? And the answer is that it is a simple way of making a remote process execute some arbitrary code, whatever code is in your DLL. Windows uses these DLLs, and it always, always has, and it's sort of DLLs are sort of specific to Windows and in the way that they work. I mean, of course, other operating systems like Linux, they have modules, modules as well that contain binary executable code. I think in Linux they're like .so files or something as opposed to .dll, but it doesn't matter. In Windows, sorry, not DLL entry. It's DLL main is what we're looking for. So in Windows, each DLL is going to have a DLL main function. And this part is important. It's intrinsic to the way that the Windows operating system functions, that when any process on the entire machine calls load library, see here it is, a DLL loaded or unloaded using load library. So when any process on the system calls load library to load a DLL file, a function inside that DLL is automatically executed. A function called DLL main inside there is automatically executed no matter what. And that means, it's an easy way to execute some code because, like I said, the remote process is automatically going to execute DLL main inside of your DLL, no matter what. I guess I'll go ahead and mention now, in practice, when you're writing a DLL, you should typically do as little as possible within your DLL main. And the reason for this is because one of the largest, most infamous class of bugs in the Windows operating system are so-called loader lock bugs. And this occurs when a process attempts to load a DLL, then we are executing that DLL's DLL main function, which is what we're looking at on the screen right here. When that happens, that thread, whichever thread is loading this module, it grabs a per process lock called the loader lock. Okay, and whenever this thread has possession of this loader lock, whenever this thread owns the loader lock, that means no other thread in this process can load any DLLs. So this can easily lead to deadlocks. For example, if your DLL main contains some code that, whether you know it or not, attempts to load another DLL recursively, you won't be able to do it, and you will deadlock your entire process because your thread owns the loader lock, and then it attempts to load another DLL while it already owns the loader lock. When you attempt to load another DLL, you try to acquire that loader lock again, which is already owned. So you're going to deadlock there. All the other threads in that process, similarly, when they try to load a DLL, they're going to sit and wait for the loader lock to become free. So if you deadlock for any reason while you hold the loader lock, all the other threads in the process are going to just sit and wait and hang and be hung forever, waiting for the loader lock to become free again. Hopefully that makes sense. It's an important thing to keep in mind when you are designing a DLL, any DLL, whether it's for, totally legitimate use or not. So that is a brief history and explanation of DLL files. So now let's go ahead and get started on our utility to load any arbitrary DLL into any other arbitrary remote process. First thing I'm going to do is fire up Visual Studio, which we have already talked about. You'll notice mine says preview. This is basically just the preview channel. Doesn't matter if you use preview or not. We are going to create a new project, and we are going to just start an empty project. So typically I always start with just empty projects because I don't I don't need any boilerplate code. I don't need any template type stuff. Just empty project is the way to go. And I'm going to name it remote DLL injector, and goes into that directory, and place solution and project in the same directory. That's fine. I'm going to hit create. Now you'll notice that it defaulted to a C++, Windows project, console project. Okay, so if you click on Get Tools and Features, this brings up the Visual Studio installer. And this is what you'll see when you're installing Visual Studio for the first time. You get to choose a whole bunch of options in here. And if you don't like what you've chosen, you can modify the installation later. Basically, I just wanted to show you this for those of you who have not installed Visual Studio before. You're going to want to check like this type of stuff. Like I personally, I don't really need any of the C# stuff or .NET stuff, though I think I may have included some of it previously. We're not going to be using it in this particular video series. What you really want, you want like C++ core desktop features. That's what you want, so make sure you've got selected the C++ stuff, C++. There you go. There you have it. So whatever I have selected and not selected, that's pretty much what you want to copy if you intend to follow along with me. I think you can get most of this stuff. Like I didn't select any of this stuff custom. I just basically just selected that right there. This right here, desktop development with C++. That's what I selected. And I think that pretty much covers you for anything that you may want. Okay, so now here we have our new project called Remote DLL Loader. We're going to go to Source Files over here in the Solution Explorer dialog. We're going to add a new item. And the new item we are going to add is, okay, so it says C++ file.cpp. But what I'm actually going to do over here is I'm actually going to change that to .c. You don't have to do this, but I like to do this, mainly because I like C and I don't really like C++. C is all you need for the kinds of things that we're going to be doing. So basically, if you name your source code files with .c, a .c file extension, Visual Studio will treat that as a C-only source code file. So you won't be able to use any C++ in this source code file. First thing we're going to do is, since we're programming on Windows, what you're going to include in almost all of your projects is the windows.h header file. And we're just going to start with this right now, but we're going to change that here in just a second. But first, what I want to point out is this is something that I always do to any new Visual Studio project. The first thing I do is I'm going to click on the project, I suppose. Like this line, this one is the solution. A solution may contain one or more projects. Remote DLL injector, this is the project. And at this level, I want to right click and go to properties. Now these property pages, there are a few things that I like to set straight before I do any coding. You can see here that you can set these items for, you know, the debug build, the release build, or both. You can set this for x86 or 32-bit, 64-bit, or both. Okay. So one thing I like to do is I like to just go here to output directory, and I like to just standardize these. So I'm going to copy, I'm going to go to, I'm going to set this for all configurations, all platforms, and you'll see here that it has different options. I like to make it this the same for all configurations and all platforms. Okay, and the same thing with the intermediate directory. I'll just go paste that in here and just make a temp directory. There you go. All right. Anything else I need to change in here? Nothing. You know, you can fiddle with this if you want to try to use, like, you know, brand new C standard stuff, but I'm not going to. All right, then we go to advanced. Now you'll notice again, if I go to, yes, I want to save the changes I made previously. See, you'll notice that it changes depending on, like, if I'm looking at the debug configuration, you'll see that it's set to use debug libraries. If I put this on release, it'll say use debug libraries equals no, you know, all this kind of stuff. So you have to pay attention to whether you want this stuff to be applicable to the debug build or the release build. One thing that is important to talk about in here is the character set. This is another sort of infamous thing in Windows programming. Is, do you want to use the ASCII character set, which for some reason is called the multi-byte character set, and there's a very sordid history behind why that's called the multi-byte character set, but practically what that really means is ASCII or ANSI, which means you know, each character is 1 byte. Or do I want to use the Unicode character set? And the answer is 99% of the time, for any new projects that you're going to make on Windows, you want to use Unicode. Okay, so you want to go all Unicode all the time, everywhere with Windows. In Windows, Windows is unique among operating systems in that we use UTF-16, which you know, everyone else basically has standardized on UTF-8 as far as I know. Most people consider UTF-8 to be superior. Windows is pretty much the only guy that uses UTF-16. Now, UTF-16 is a variable length encoding where each character can occupy either 16 bits or 32 bits. 99.9% of the time, each character will only require 16 bits of memory. However, there are extended characters in UTF-16, like such as emoji, for example, that will require 32 bits of memory. Anyway, the reason why you want to use Unicode is because, you know, Windows is natively a Unicode operating system. So what this means is when you use Windows API and you use the ASCII or ANSI entry point, Windows will have to convert that text into Unicode, do its processing, you know, depending on whatever API you called. Then it will convert it back into ANSI and give you the result. Um, that translation leads to a small performance penalty, or it could be a moderate performance penalty, depending on how you're using the API. So, you know, you basically, you want to avoid that translation if at all possible. So, you know, just stick with native Unicode. Um, now, there is a if you're already subscribed to this channel, you already know that uh, I have another video series where we're programming a video game from scratch, and in that video game, I'm actually not using Unicode at all. And that's sort of a do as I say, not as I do type of thing, because in that video game, I'm basically just, I'm using the ASCII character set only because I'm making a retro video game where I basically I'm just trying to make it as easy as possible to read the code and to understand the code. So you know I am using ASCII in that project, but for all other projects, for every project that you create, you should use Unicode. Um, all right, enough about that. Let's go on to. Oh, and by the way, this C and C++ um, section will only show up after you have added this C file over here or CPP file over here. So if you're looking for this and it's missing, it's probably because you have not added this source code file over here first. Typically, I like to go ahead and enable all warnings, and I'll do this for all configurations and all platforms. I like to enable all warnings. Now, this is, we'll talk about that later. I just like to enable all warnings because I like to program in a very disciplined, very concise manner. We'll go down here to code generation. I think this is the last thing we need to talk about. When you go to debug, and right here, runtime library is currently set to multi-threaded debug DLL. What this means is that you can choose to either have the runtime essentially baked into your executable or have it as a separate DLL. Now, I personally like to always have it baked into the executable because this makes it more portable. So like if I give you this executable to run and it already has the runtime baked into it, the exe file is all you need, as opposed to where if I chose multi-threaded debug DLL, then it generates a separate C runtime DLL, and I have to make sure and give you both the .exe file and the DLL file to go with it, or else you may not have the proper DLL on your machine to run it, and it won't run. It'll say you're missing this DLL. So I always like to choose this option. Of course, the downside is that it makes your exe file much larger, but I don't care. Actually, this needs to be set to debug. Make sure that this is set to debug, because if it's not set to debug, then you will have a very hard time debugging it. Okay. Similarly, I'm going to go to release. In the release build, I'm going to set it, instead of multi-threaded DLL, it should just say multi-threaded. Yep. All right, and those are pretty much all the things that we need to worry about there. I know I'm going to need Windows.h. I also know I'm going to need to do some standard I/O stuff. This is like printf, so where that comes, you're gonna need stdio.h if you want to do like printf, and also things like string length and stuff like this. All right, so I don't actually want to do int main. I want to do something a little better than that. We'll do WMain. There, this is what I want, WMain. WMain is just the more proper Unicode version of the main function. So this is the entry point of our program. So this int argc, what this means is this is the count of arguments, command line arguments that are passed in to our program. What I mean by that is, so this is a command line window, by the way, and I'll make the text bigger so you can see it. If I'm going to run an executable called foo, if I run that on its own by itself with no parameters, argc will be 1 because the executable name itself counts as one of the arguments. So that's 1, and then if I pass it another thing that's just like a process ID, for example, that'll mean argc is now 2 because there's 2 things on the command line. And argv is this is a pointer to an array of strings, or is basically an array of strings that represents the command line arguments that have been passed into us. So, arrays starting at 0, that means argv0 is going to be this guy, and then argv1 will be that guy. And then if I have more, command line parameters, then argc is now going to be 3 because I have 3 things on my command line. And then this is argv0, argv1, argv2. Okay. So how I'm envisioning this working out is the show where we do sketchy stuff with the Windows API. How I'm envisioning this command line utility is going to work is going to be something like this. Usage remote DLL injector, and then process ID, and then path to the DLL that we want to inject. What this means is that this command line utility is going to have it should always have exactly 3 parameters on the command line, including the name of the executable itself. So if argc does not equal 3, then we are going to let's see, wprint, which is Unicode. We're going to print off the usage. And suppose I can go ahead and, because since this may be duplicated multiple times, I'm going to usage string equals, and then with Unicode strings, you have to prefix it with this L symbol that lets the compiler know that this is going to be a Unicode string and not an ASCII string, which means that every character is going to occupy at least 16 bits as opposed to 8 bits. Anyway, usage is going to be remote DLL injector.exe process ID path to DLL. Okay. Okay. Now, assuming that the user has passed the correct number of arguments, we still need to validate that they are that they make sense. So a process ID it should be a D word, which means it's an unsigned integer, which means that it can't be, it cannot be negative. It's unsigned, a D word. Process ID. It also can't be 0. Now what we need to do is, since the command line parameter is going to come to us as a string, we need to convert that string into an integer and a Unicode string at that. So you may be familiar with A2I. We can't use that. It's going to be something like W to I, underscore W to I. Takes in a string, which is going to be argv1, right? Because argv1, this is argv0, so this is argv1, that's the process ID. And if that returns 0, let me just double check how that works. The return value is 0 if the input cannot be converted to a value of that type. Now, even though W2I returns an integer, we're going to cast it to a D word anyway. process ID equals that. D, all caps, with capital D. So we'll do assignment and comparison at the same time. If process ID equals 0, then something is wrong. So we're going to just bail at that point. We're going to say F. Also, we should include a new line here. Okay, we're going to say, and also we need to include an L here, I believe. All these things need to be prefixed with this little L character since they're Unicode strings. Okay, we're going to say cannot convert process ID. And again, we are going to, forgot a parentheses here, parenthesis. And then we are going to remind the user how to use this program. Maybe they forgot. Secondly, we need to verify that that path to the DLL is a valid path and that it exists, that it's actually a valid DLL. DLL path. Now we're going to, I assign it null here because I want to first make sure that they did actually supply the correct number of arguments first. So I'm going to wait until after that to assign DLL path a value. DLL path equals argv2. Right? And what I mean by that is, like, I want to make sure that that argv2 actually exists first before I go assigning the value of argv2 to something. Okay, so now we need to create a little function that verifies for us that this DLL path actually exists. And to do that, we are going to make a new function, and we're going to call it. It's going to return a Boolean, and we're going to call it file exists W. The W stands for wide. You'll see this all throughout the Windows API. All the Windows API functions have a version that ends with an A for ASCII or ANSI, and a version that ends with W for wide. As you would expect, one of them accepts ASCII characters, and one of them accepts Unicode characters. All right, wchar t. This is a pointer to a Unicode string file name. This is pretty easy. File attributes equals, this is a Windows API function, get file attributes W of that file name. And we need to basically just return file attributes does not equal invalid file, which that will be the return value if the file does not exist. And we also need to make sure that it's not a directory. File attributes will check the file attribute directory bit. Okay, so essentially this expression will evaluate to true if the specified file name exists and is not a directory. Pretty simple. So we'll say if file exists W DLL path, we'll say if that is false, DLL path with a capital P. Then we were going to say wprintf cannot locate DLL, just to let the user know what went wrong. And once again, we're going to remind the user how to actually use this program in case they forgot, and then we're going to return. All right, so now at this point, we have validated our inputs to a reasonable degree. So we're going to actually start the work of injecting the specified DLL into the specified process. First thing we need to do is call OpenProcess, which you will notice that this function does not have the A version and the W version. That's because this function does not take any strings. It takes a D word, a Boolean, and another D word for process ID. So let's go ahead. For desired access, we're going to do process all access, which you need in order to, write something into that remote process's virtual address space, into its virtual memory. Bool inherit handle is false. We don't care about that. And then the process ID will be our process ID. Okay. Now we need somewhere to store this handle. OpenProcess returns a handle. So we're going to do handle process. We're going to name it remote process handle. We're going to initialize this to a value of invalid handle value. I mean, you could probably initialize it to 0 or null 2 if you wanted to, but it doesn't matter. Remote process handle equals OpenProcess. We're going to say if remote process handle. Actually, let me double check what this function actually returns. All right, if the function fails, the return value is null. So we're going to say if remote process handle, then that means it succeeded. Else, that means we failed. So let's go ahead and type in wprintf open process failed with error 0x%08lx. And this format specifier just means, pad this with 8 zeros, and this is a long, and then the x means display it in hexadecimal. And then we need a new line here. We need a semicolon here. And then the value will be get last error. So that way at least you have some idea of why it failed. Now, assuming that we succeeded, we need to do something here. We need to create a handle for a different module. We basically need to get the address of the load library function. You see, every process on Windows has its own virtual address space. So certain DLLs, such as, let's find kernel 32. All right, kernel 32 load address. Okay, and this is in LSASS. This is in the lsas.exe process. You'll see the load address is 8CEC0000. Let's go to another process like Notepad++, find kernel 32.dll. We'll see that the load address is the same, 8CEC0000, right? So we can use that little fact to assume that the address of kernel 32.dll is going to be the same in every process. So let's go ahead and make a kernel 32 module handle. Okay, we'll go back down here and we'll do And I'm purposely leaving this blank for now because I already know ahead of time that we're going to run into issues with access denied errors if you are not running this as administrator. So I'm sort of leaving that part open-ended. It'll all come together here at the end. I'm going to go ahead and load this kernel32 module handle equals get module handle w, and then kernel32.dll. And if that failed for some reason, which it never should, but just in case it does for some weird reason, then we're going to do the same thing where we exit here. Now that we have the address of the kernel32 module, we need to find a function within that module called load library. And let's see, we probably need a variable like load library address, and it's going to be equal to get proc address. It accepts a module handle, which is going to be our kernel32 module handle. And where's the W version of this function? See, because it takes a long pointer to a constant string. That's not Unicode. That's weird. Load library W. Anyway, I mean, I think that'll work. I just expected there to be a Unicode version of this since it accepts a string, but it looks like there's not. Anyway, we need to make a variable called, and it's just a memory address. It's just going to be a void star load library address. And for this, we'll do get proc address. I'm sure it returns null if it failed. So if load library address is null, then we failed and we should exit the program. Get proc address failed with that error, get less error. Okay. Now we have the address of the load library function, which is exported by the kernel32 module. What we want to do now is we want to create a remote string. We want to write our DLL name into the remote process. And again, this is because the address of our DLL name here in our process, a remote process is not going to be able to read this local variable in our program. We need to go ahead and duplicate this in the remote process. We need to inject this DLL name into the remote process, into the memory of the remote process. So to do that, what we're going to do is make another void star, and we're going to name this remote memory for DLL name. Okay, come back down here, remote memory for DLL name. equals virtual alloc ex is the function that we use to allocate memory, and we can allocate memory in a remote process too, because remember we already have the handle of the remote process, which is, what do we call it? We call it remote process handle. Remote process handle. Okay, we need an address, which is going to be null, and that means virtual alloc is just going to figure it out. Is going to place it wherever it can. The size of the memory that we need to inject into the remote process, or the allocate in the remote process, is going to be the length of our string, which is DLL name, which is DLL path, not DLL name. The length of it times WHRT, right? Because each character, it takes up 2 bytes. So that's how much memory we're going to allocate. Should I also allocate an additional 2 bytes for the null terminator? I don't know, but we're going to skip that for now. Let me get all these on separate lines just to make it a little nicer to read. Okay, allocation type is going to be reserve and commit, mem reserve, mem commit. And then finally, the page protection is going to be page read write. We're going to be writing into this memory, so it is important that we have write access to it. As usual, we're going to do if remote memory for DLL name is null. So if that failed, then we're going to complain about it and bail. To do virtual alloc ex failed with that error code. All right, so now, assuming we have memory in the remote process, we are going to do write process memory. In the remote process, which is going to be remote process handle, the base address will be what we just created, remote memory for DLL name. The buffer is going to be our DLL name. So we're literally just writing that string, which is the path of our arbitrary DLL path. That's the, there it is. And then let's see, size is going to be the same size as before. The length of DLL path times size of WHRT. And then number of bytes written, we're going to ignore number of bytes written. And we're going to say if this function call equals 0, that means it failed. We are going to complain about that and then bail. Right, process memory failed with error. All right. So now we have successfully written the string of our DLL path into the remote process's memory. What we need to do now is, the last thing we need to do now is create a remote thread in that process. We're going to create the remote thread in that process, and it's going to run load library because we already know the address of load library, right? So here's what we're going to do. Create remote thread. We are going to remote process handle. We're going to execute it in that remote process, or we're going to create the thread in that remote process that we specified. Security attributes we don't need. Stack size will be default, which is 1 megabyte, I believe. start routine, this is very important. We're going to need our load library address. And we should probably go ahead and cast this to LP thread start routine. Okay, and then our parameter, this is also very important. Our parameter is going to be the remote string that we wrote just a second ago, the path to our DLL. So we're tricking the remote process into calling load library on the DLL that we want it to load. So this is going to be remote memory for DLL name, because remember, our local copy of that string in our program is not at the same address as the, we created a duplicate of that string in the remote process. It's important that we use that and remember that these two processes have separate virtual address memory spaces. Okay, what next? What next? Parameter we got. Let's make sure I'm on the right thing. Parameter. Okay, creation flags. I don't think we need. And then the thread ID, I believe we don't need the thread ID either. Do I have that correct? So we're going to wrap that up in an if statement also, and we're going to say if create remote thread, if that failed, so if it equals null, then we are going to complain about it and exit the program. And then if all that succeeded, we're going to say successfully injected DLL into process with PID process ID. Okay, so I think our program is done at this point. So let's build it and see what happens. All right, so we're on debug, x64. Well, that's fine. We have 0 errors, 29 warnings, which most of these warnings can be suppressed. They originate from the windows.h header file. So we can do a pragma warning push 0, and then we include that, and then pragma warning pop to restore our warning level back to all warnings. So it's just the windows.h header file won't compile cleanly with no warnings at the current warning level that we have, which is enable all warnings. So if we temporarily disable warnings and then we include windows.h and then we pop our old warning level, which is all warnings, pop that back, then the warning should go away, I think. No, did I do that wrong? I believe I did this correctly, but sometimes with Visual Studio, it takes a while to catch up. So, matter of fact, let me go ahead and stop. Let me go ahead and shut down Visual Studio and restart it. Sometimes it just takes a minute for Visual Studio to catch up, and let me just rebuild. No, I can't get rid of these. I'll work on getting rid of these warnings, but they don't actually, it doesn't matter. Let's just ignore them for right now. I'll suppress them properly later. Let's go to this one. Format string requires an argument of type int, but very variadic argument. One has type dword. LD. Is that better? Does that make you happier? Yes, it does. Okay, environment unreferenced variable, so we'll do unreferenced. Isn't that how you unreferenced parameter environment P? That basically just tells the compiler, hey, we're not using that formal parameter. Non-standard extension function data pointer conversion in expression. What? Oh, I probably just need to do it. There's probably a cast missing here. Let's try that. Yeah, there we go. So now we have no warnings. At least we have no warnings in our own code. We have some warnings that originate from windows.h, but like I said, we'll suppress those later. All right, so finally it's done. Let's go and run this, shall we? Let's find it. Source, repos, remote DLL injector, x64, debug, and there it is, remote DLL injector.exe, remote DLL injector.exe. If you run it with no command line parameters, you'll see that it just tells you how to use the program. If I give it like a nonsense value for a PID, and then, again, I have the wrong number of parameters. So now you'll see the message cannot convert process ID. So let's fix that and give it a valid process ID. Let's inject into calculator.exe. Okay, so we have calc.exe running. Let's find it here in Process Explorer, calculator app. It's no longer calc.exe, it's now calculator app. And a process has a process ID of 10,404. So let's fix this to say 10,404. Okay, now the process ID is valid, but it says now cannot locate DLL. So we need to supply the path to a valid DLL. And I don't have a DLL yet. Oh, that reminds me of something. Let's go ahead and get this out of the way. The kinds of stuff that we are doing and the kinds of stuff that we will be doing in this show really agitate antivirus programs. We are definitely going to do some dirty things that is going to trip our antivirus software. So let's go ahead and go to Windows Defender here. View options. No, not notifications. Defender. Here we go. Virus and threat protection. Virus and threat protection settings. Do we have an exclusions here? Exclusions. That's what we're looking for. Add or remove exclusions. Add an exclusion for a folder, and we are going to add an exclusion for our entire repositories folder. You can see I have some other projects in here, but here's our remote DLL injector. Anyway, we're going to basically exclude that entire directory so that Windows Defender does not scan it. And that's, like I said, a lot of the stuff that we're going to be doing will really trigger Windows Defender, so you might as well exclude it. We may get into trying to evade Windows Defender later, but that's a much more advanced topic for a much later episode. Anyway, so we need a DLL, and I'm just going to find some arbitrary DLL that is not already loaded. So we're going to do, I don't know, we just need to find one. All right, let's find one. Okay, dps.dll. I don't know, I have no idea what that DLL does or what it's for, but dps.dll, it's in the system32 directory. Let's make sure that it's not already loaded in our calculator process, DP, nope, it is not. All right, so we're going to use that as an experiment, as a sample. So we're going to type Windows System32 dps.dll. Hit it. All right, successfully injected DLL into process with PID 10404. And if you noticed in the background, you probably saw a flash of green down here in this lower pane, which means, looky there, dps.dll has been successfully injected into calculator app.exe. And we can do this with any arbitrary DLL. Now, there's one last thing I need to show you. This won't work. For example, let's find a very interesting process on the machine, which is lsas.exe. All interesting security stuff on the machine basically goes through lsas.exe. So this is probably the most interesting process on the machine for most of our purposes. So lsas.exe, you'll notice PID 684. So let's try to inject dps and dps.dll. You'll see that it is not already loaded. Let's try to load it. Process ID 684. Process ID 684. And this is not going to work. OpenProcess failed with error code 5, which is access denied. So you think, well, maybe we need to elevate. Command prompt will go to run as administrator. Okay. We'll go back to our directory over here. Okay, remote DLL injector, process ID 684, and then Windows System32 dps.dll. Now, even running as administrator, OpenProcess failed with error code 5, access denied. This is something that we need to overcome. Okay, OpenProcess. So if it succeeded, then all well and good. But if it failed, then we need to work on something else. It fails even as administrator. And the reason why is because there is a particular privilege in our token that we need to activate, and then we need to try again. Create a current process token handle equals null. We need to create a UID. We're going to initialize that to zeros. We need to create a token privileges local variable. We're going to call it token privileges. We're going to initialize that to 0. We need to open our own processes token and give ourselves, we need to enable a particular privilege for ourselves first before we try to make that open process call again. So we're going to do open process token get current process, and then we need to do desired access token adjust privileges, and then the token handle is going to be an output. So we need to supply the address of our current process token handle variable. And of course, if that function fails, we do our usual, wprintf open process token failed with error 0x%08lx, and then get last error, fine, and return 0 there. Okay, all right, now assuming that the open process token call worked, we need to look up privilege value W. System name null means local system. The name of the privilege is se underscore debug underscore name. And then we need to give it the output. We need to store this output into our UID. And then we need to populate some extra stuff. Token privileges dot privilege count equals 1 because we're only enabling one privilege. Token privilege dot privileges, which is an array. So the first element of that array dot LUID equals our LUID that we already looked up. And then finally token privileges dot privileges 0 dot attributes equals SE privilege enabled. Then we are going to if adjust token privileges, we're going to do token handle current process token handle, that's us. Bool disable all privileges, that's going to be false. We are going to give it the new state. These are the new privileges that we want to enable, which is going to be our token privilege, token privileges. All right. Buffer length we can ignore. Previous state is going to be, we can ignore that too because we don't need the previous state. That's like if you want to restore the privileges to their previous state, which is, useful in a lot of cases, but not here. And then finally we have return length, which is we don't need. We probably better get these casts in or else the compiler will complain about it. So we'll just do these casts. They're not strictly necessary. I just like to keep the compiler warnings clean. Okay, so if all of that equals 0, then we complain about it and bail. Okay. Now we have given ourselves the debug privilege, which means we can try again. We can try our OpenProcess again. If remote process handle equals null, then we've done all we can do. We need to go ahead and exit. Okay, let's compile that, see what happens. We don't have any extra warnings besides the Windows.h ones. So let's try again. Remote DLL injector 684, and we're injecting dps.dll. No output. Hang on. It didn't work. Okay, so it's probably just a mistake in our logic here. Let me go back and see what happened. We'll do sprinkle in some debug text here. Successfully enabled debug privilege. Just to make sure this code is running. Yep, that code is running. Oh, there it is. Get rid of that return. We don't want to return there. Okay, rebuild again. Successfully enabled debug privilege. Successfully injected DLL into process with PID 684. And if we go over here to Process Explorer, what do we see? Other than our newly injected dps.dll, and again, that's just a random arbitrary DLL. In a future episode, we are going to craft our own DLL that does really interesting things. And as you can see, we've injected a DLL into LSASS here. That concludes episode 1. That is what I wanted to show you. in the pilot episode of Dark Mode is injecting a remote DLL, injecting a DLL into a remote process. So this episode has gone on for long enough. That's all I'm going to show you for today. In future episodes, we're going to build upon this. We're going to use our utility. We're going to write our own DLL, inject it into another process, probably LSAS, to do much more interesting things in the future. So if you have any questions or comments, please leave your questions and comments in the comments sections. I'll be happy to answer any interesting comments. If you enjoyed what you saw today, if you want me to keep making these kinds of videos, please like and subscribe. If you want to get in contact with me, you can find me on Twitter. You can. Another important fact to note is that I will be publishing all of this code to my GitHub, which you can find the address to my GitHub in the description for this video. I think that's all I wanted to say. So thank you very much for watching, and I will see you next time.